Hello students, welcome to my Abhyas. My name is Sahana KS and I am your physics educator. So we were discussing the SI units and the standard of the SI units, right? So coming to the next thing, we have the ampere. So we have heard this ampere somewhere, right? So it was heard in the chapter electricity of your 10th standard. Okay, so in the 10th standard, you had a chapter which was called as electricity, and that is nothing but it is given by I, or that is V equal to IR, or I is equal to V by R. Clear? So coming to this amperes, what is the ampere? So it is a SI unit of electricity or current. Clear? So what is the standard quantity? How the standard quantity will be taken? So we'll just check. So the ampere is that current which when flowing into thin infinitely long. Okay, so the current which is flowing into thin, infinitely long, straight parallel conductors. So there are two thin, straight parallel conductors. Okay, and in that they are kept 1 meter apart. So we have mentioned here it has to be kept 1 meter apart in vacuum, which produces between the conductors a force of how much? 2 into 10 raised to minus 7. So whenever the current is whenever the current is made flow through this wire, that is parallel conductors, what is happening? The force is, the conductors are giving a force of how much? 2 into 10 raised to minus 7 Newton per meter length. So for per meter length, 2 into 10 raised to minus 7 was the force. Okay, so that was considered to be the standard quantity when compared to the other things. So ampere is measured by nothing but it is taken by the two infinitely long straight conductors, and when the current is flown through those conductors, then there is a force of 2 into 10 raised to minus 7 Newton per meter. Clear? Moving on to the next, we have the other unit which is called as Kelvin. So Kelvin is a SI unit of what? It is a SI unit of temperature. Okay, so temperature we have been across a lot, especially this year, right? So what is temperature, or the measure of hotness or coldness of a body is called as temperature, and the SI unit of temperature is Kelvin. So Kelvin is taken as the fraction of 1 divided by 273.16. Okay, so it is taken by the fraction of what? 273.16, that is 1 divided by of the thermodynamic temperature. So there is a thermodynamic temperature and it is 1 divided by 273.16. So of triple point of water. So what do you mean by triple point of water? So water has like 3 stages, right? One is, we call it as ice. Okay, the other one is water itself. Okay, or you can take it as a liquid form. And then the third one is, it is nothing but it goes into the gaseous form or gaseous vapor. You can say vapor form. Right. So, what is triple point? So, triple point is nothing but it is the temperature at which ice, liquid water and water vapor are in equilibrium. So, all these 3 phases, that is the ice, okay, and the liquid water and also the vapor are in equilibrium. So, you can see the picture here. It is so beautiful that the picture where the triple point of water has been shown, where you have the ice, you have the liquid water and also you have the water vapors in this. So this is the equilibrium state, and that is nothing but the standard quantity for measuring the temperature, and it is given by Kelvin. So Kelvin is a fraction of 1 divided by 273.16 of the thermodynamic temperature of triple point of water. You have to remember this. Clear? Going on to the next, we have the next important, you can say. Okay, so I think you people haven't heard about this anywhere, but this is the first time you are hearing about the luminous intensity, or we call it as the candela. So candela is nothing but it is the SI unit of luminous intensity. So what is luminous intensity? For example, see here, whenever you light a candle, what happens? Whenever you are nearer to it, just bring, for example, let this be a candle. So when you bring your hand here, okay, there are chances of burning. But once you take it far away, what is happening? The intensity of that flame is decreasing, right? So as it is decreasing, what is happening? The luminous, that is the whatever lumen is there is getting decreased, right? So that thing we call it as what? Luminous intensity. So the luminous intensity is measured by a SI unit which is called as candela, and it is denoted by CD. Okay, so what it is denoted by? It is denoted by CD, and the candela is nothing but it is the SI unit of luminous intensity which is given or which has a source that emits monochromatic radiation. So this emits what type of radiation? Monochromatic radiation. So monochromatic radiation of frequency 540 into 10 raised to 12 hertz. So it gives out radiation of 540 into 10 raised to 12 hertz and has a radiant intensity of that direction, that is 1 divided by 683 watt per sterdian. Sterdian, you will learn it in the next sessions. But for now, just remember the candela is nothing but it is the SI unit of luminous intensity. And of what luminous intensity? So it is luminous intensity in a given direction, okay, of a source that emits a monochromatic radiation of frequency how much? It is 540 into 10 raised to 12 hertz. So you can see the picture, the candle is lighted here, okay. So for example, if you have to light a room, okay, so first thing what you do, you just check where the sunlight is coming from. So where the sunlight is like more intense, you won't be placing the tube light there, but instead you will be placing it the other way around where the darkness is more, right? So what are you doing then? You are judging the intensity of the light. So where the intensity of light is more, you are not placing the tube light there, but where it is less, you are placing the tube light there. Clear? So that is what we call it as luminous intensity, and the SI unit for that is candela. Okay. So moving on to the next, we have mole. So this you come across in chemistry a lot, and this is also a fundamental basic unit where everything has to be counted from a mole. Clear? So what is a mole or MOL? We call it as MOL. So a mole is the amount of substance. So the SI unit of amount of substance is mole. Okay. So the mole is the amount of substance of a system. So it is a amount of substance of a system that contains as many elementary units, that is as many as atoms or molecules as there are atoms in 0.012 kg of carbon 12 isotope. Okay, so the best example for this is what is a mole is the amount of it is the SI unit of the amount of substance. So if it is the SI unit of amount of the substance, what is the standard unit should I consider? So the standard unit which I have to consider is, it is nothing but 0.012 kg of carbon 12 isotope. So you can see here in the picture, there are some balls at the down and there are some balls at the on the weigh scale. So what are they doing? They are measuring how many atoms or molecules can be weighed. That is around 0.012 kg of carbon 12. Okay, so that has to be the standard unit, okay, whenever you are considering the SI unit of a mole. Clear? So moving on to the next, what we have, because these are the 7 main SI units where we just saw the standard SI units. Like for example, I gave you one theory where there is a big building and there are many smaller buildings, and when you compare it with the smaller buildings, you say that this is a big building. But in the city, there are other more big buildings than the building in your lane, right? So similarly, we have seen the SI units where the mass is given by nothing but kg, and the length is given by meter, the time is given by second, the current is given by ampere, then we have the temperature which is given by Kelvin, and the luminous intensity by candela, and the amount of substance by mole. Clear? So now adding to this, there are other 2 units. So why did they introduce these 2 units? So they introduced these 2 units because what happened was, these were all linear cases like time, second, length, etc. But what about the rotational motion? Whenever we considered a rotational motion or rotational movement, what happened? Why was like there were no SI unit to judge the rotational motion or the solid angle, you can say. So for that, they gave other 2 supplementary units where we can use it in the circular motion or also the rotational motions. Okay, and that were called as radian and steradian. So we'll look into radian. So what is a radian? So radian or 1 radian, I think you people have come across this in your maths subject, radian. And even if you just check your scientific calculators, you have the degree scale, okay, and another one will be the radian scale. Okay, if you just check in your scientific calculators, if you have, okay. Then what is a radian or 1 radian is equal to? So 1 radian is nothing but it is the angle subtended at the center of a circle by an arc whose length is equal to the radius. So you can see here 1 radian is this. Okay, that is the I have taken 2 radius r and this is a arc here. Okay, so what you can say, what is 1 radian? 1 radian is nothing but it is the angle between or the angle subtended at the center of the circle. Okay, at the center of the circle by an arc whose length is equal to the radius. Okay, so the length of this will be equal to the radius. So that we call it as what? A radian. Clear? So moving on to the next, we have for the solid angle. So this was for a plane angle. Next we will look into the solid angle. So once we consider the solid angle, it is called as steradian. So steradian is nothing but it is a solid angle, okay, which is subtended at the center of the sphere. So it is subtended where? At the center of the sphere. So you can see here, right? So spherical area of its with circular boundary and having area equal to the square of the radius of the sphere. So you can just take this as s divided by r square, that is theta is equal to, or whatever the angle is equal to, that is s divided by r square, where s is the surface area here, okay, and this is nothing but the solid angle. Okay, so I'll just mark it in black. So this is the solid angle and this is nothing but the surface. Okay, and this cone is nothing but the area which we have considered. So the best example for this is, I think you have all eaten this cornetto ice creams, right? So at the last what happens, you will be having the chocolate. Okay, so the chocolate whatever is there, the chocolate which is at the last, okay, so that is everyone's favorite. So that chocolate is nothing but the solid angle, or the you can say, yeah, it is a solid angle, and you can measure that with the steradian. Clear? So this is about the supplementary units. Okay, so moving on to the next, what we have, like we have studied the SI units, and then what we have to study is how to apply them, like how to write those things. What are the rules to write the SI units? Can we use what you can say, the scientist name with capital A? Can we use with capital S, or should we use a small letter? So there are some rules for you to understand the SI units. Clear? So moving on to the next slide, we have the rules, okay, and also we have some of the prefixes which we will be dealing with in the next. Okay, so after this we have this advantages of SI units. So after the advantages, I'll tell you the rules. So coming to the first one, that is when we consider the advantage of units. What were the advantages? Because we got to know what were the disadvantages, and because of that SI units were like they were given. Okay, but what are the advantages now of the SI units? So the SI system is logically superior. So this is superior of all the systems. That is, it may be FPS, it may be CGS, it may be MPS. Because even in some countries nowadays they use, like especially the British countries, they use FPS system. Okay, but while communicating and while having the theories or while having some discoveries and invention, they use the SI units. So what happened? It is logically superior to all the other systems. So the SI unit is superior. Okay, in one word. Then SI units do not vary with time. So SI units do not vary with time. Whatever the time is, the SI units are the same. They do not vary with time. Okay, as they are based on properties of atoms, because they are considered from the properties of atoms. Everything has a standard, and that standard contains atoms. Clear? So the first one is nothing but it is superior to all, and the second one is nothing but it is not varying, or it does not vary with time. Okay, moving on to the third one, we have the SI system, okay, of units are coherent system. Okay, these are coherent, and in which the units of derived quantities are obtained as multiples or submultiples of certain fundamental.